everyone, this is Mrs. Snowbeck. Today we are going to do Unit 3, Lesson 4. We're going to start off with two vocab words. The first one is theorem. A theorem is kind of like a theory that someone had and it has been proven true. So just like in science, you can have a theory and you can do lots of tests and you can prove that your theory is true. Same thing in math, you can do the same type of thing. And once it's proven true, then it is called a theorem. So it's a statement or a conjecture that can be proven true by undefined terms, definitions, and postulates. So basically, you come up with an idea and you prove that it's true. Postulates, on the other hand, are a statement that we know must be true, but we accept it to be true without totally proving it because a lot of times it's humanly impossible. I think of an example like a positive number times a positive number equals a positive number. You can try a million different combinations of multiplying two positives and you'll get a positive, but it's humanly impossible to do every single combination. Like you wouldn't be able to do it in a lifetime because numbers go on forever. And so that would be a postulate, something that we know is true and we accept it to be true without actually being proven. So yesterday we talked about how to determine if two polygons are congruent, and you had to check all their matching sides and see if they were the same. And then you had to check all the matching angles and see if they were the same. And if all the angles in one polygon matched and all the sides in one polygon matched the other polygon, then the polygons were congruent. Well, triangles have some shortcuts. If I gave everyone in the class a piece of paper and a ruler, and I said, everybody, draw a triangle that has side lengths 2 centimeters, 3 centimeters, and 4 centimeters. You'd all get busy drawing and that type of thing. And the cool thing that would happen is every single person's triangle in the whole classroom would be congruent to everyone else's. They would all be the same size. And so that brings us to the side-side-side congruence theorem. If you look at these two triangles, there's a single tick mark, there's a double tick mark, and there's a triple tick mark on each of the two triangles. The three sides in one are congruent to the three sides in other. That's enough to know that those two triangles will be congruent, and you don't even have to check the angles. It's a little shortcut. So if side AB is congruent to, and now order matters, so I want to go, I think DE. See how the D matches up with the A? Because the A is between the 1 mark and the 3 marks. So then the D over here is between the 1 mark and the 3 marks. So that's kind of how I knew they matched up. Let me erase some of my marks. And then if the second side, so side BC, is congruent to, and now I think we want to go EF, if we look for the matching angles. And then the third side, let's call it AC. So it goes from here between the first and third. So that's like going to be DF if we match it up. If all three of the sets of sides are congruent to each other, then that's enough information to know triangle ABC is congruent to, again, order matters. So D, E, F. And this is called the side-side-side congruence theorem. The second shortcut for triangles is if you have a side, an angle, and a side from one triangle that match up with the other triangle. So for instance, if side AB in the first triangle is congruent to side DE, and if angle B is congruent to angle E, and if side BC is congruent to side EF, which they are because of the markings on them. If that happens, then triangle ABC is congruent to triangle DEF, and it's because of the side angle side theorem. If I told you all a side length, an angle, and another side length in that order, and I said to draw a triangle with those measurements, every single person in the whole classroom would draw the same triangle. One might be upside down or something, but if we turn the paper sideways, they would match up. The third shortcut for triangles is called the angle side angle theorem. So if you have two triangles and you know that an angle, a side, and an angle in that order, an angle, a side, and an angle in that order, if they match up, to another triangle, then that's going to be enough to say that the two triangles are congruent. So in this case, if angle A is congruent to angle D, they both have two little curves, and side AB is congruent to side DE. Again, order matters. I started at A with two curves and went to B with one curve. So then I have to do the same thing over here. Start with the two curves, go to the one curve. And then finally, if angle B is congruent to angle E, then that's going to be enough to say that triangle ABC is congruent to triangle DEF, and it's by angle, side, angle. And finally, the fourth and last shortcut for triangles is called angle-angle-side theorem. And again, the order matters. Here's an angle, and a side in that order as you go around the triangle. And so in this case, we have angle A matches up with angle D, and angle B matches up with angle E, and then we have a side. Side BC matches up with side EF. If that happens, that's going to be enough to say triangle ABC is congruent to triangle DEF, and this time it's by angle, angle, side. So we've learned side, 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 angle, side, angle, side, angle, 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 side. You might be wondering about ASS. Well, there is no swearing in math, of course, but there actually is no ASS theorem, and here's why. Let's say I start with drawing a segment, right? And then I want to draw a 58-degree angle. So I'm going to have a 58-degree angle right here. And then I'm going to make that next segment 12.8 centimeters. And coming from that, I'm going to have an 11.4 centimeter side. Well, I would get a triangle that looks kind of like this with an angle, a side, and a side, right? ASS. The only problem is this corner right here. Instead of hinging out, what I could do is hinge it in. And so what would happen is that 11.4 could end up over here instead. So my triangle would actually look like, here's my 58-degree angle, here's my 12.8, but then instead of hinging out, it hinges back in 11.4. Just because I give you an angle, a side, and a side, and I said to the whole class, draw a triangle with a 58-degree angle, a 12.8 side, and 11.4 side, they would not all look the same. It's called the ambiguous case, and there's two possibilities of how it could look. And so just because I give you an angle side side doesn't mean the two triangles are congruent. Therefore, there is no ASS theorem. Just remember, no swearing in math, you'll be fine. This is what your homework's going to look like. I'm going to give you two triangles, and you're going to try to figure out, is this enough information to prove that they are congruent? And if so, by which theorem? And so in this case, you can see I have a single, a double, a triple, a single, a double, a triple. The three sides in one triangle match the three sides in the other. And so yes, these two triangles are congruent because they have three sides that match side, side, side. Part B, is this enough information to know if the two triangles are congruent? Well, I only have one pair of sides that are marked, so I don't have one pair of sides that are congruent. Think about this side, the side that is in the middle that they share. Is that the same length in both triangles? Is it the same length in the bottom triangle as it is in the top? It is, isn't it? And so what I could do is I could put a tick mark on there, and it's going to be the same size in both triangles, but I think I still only have two sides that match up. And so this is not enough information, not enough info to prove that the two triangles are congruent. I would need one more piece of information, either another side or an angle. Part C, is this enough information to say that the two triangles are congruent? Well, if I'm looking at this, I see a double, a single, an angle. So to me, that's kind of like a side-side angle. I have the same thing up here, a double, a single, an angle. So I have side-side angle again. but that is not one of our choices. Notice it is the swear word backwards. So there is no swearing forward or backwards in math. So this is also not enough info. Not enough information there to know if they are congruent. Let's take a look at part D. Segment KM bisects angle JML. If segment KM bisects this angle up here, it cuts it perfectly in half. That's what it means to bisect something. So even though the marks weren't there, I know that those two angles with the double marks that I just drew in, I know those are congruent because that segment bisected that angle. I also know that this side in the middle is going to be the same length, MK will be the same length in the left triangle as it is in the right triangle. And so when I look at my two triangles, do I have enough information? Well, I have an angle, and a side. And do they match in the other triangle? Angle, angle, side. They do. So this one is yes by angle, angle, side. Some people sometimes question, like, how do you know which way to go around the triangle? If we have these marked and this marked, the answer is this. If you're going around the triangle and you hit two things without a mark, you're going the wrong way. For instance, if I start at angle J, I have an angle there, right? But then this side has no mark and this angle has no mark. That's two things without a mark, so I cannot go that way. So then turn around and instead of going to the right, then go to the, instead of going to the right, go to the left or go clockwise. And then you'll have an angle. You'll have one thing, a side with no mark, but then your next thing, your angle is marked. So as long as you don't have two consecutive items without marks, then it's okay to go that way. Okay, so part E, what do you think? Is there enough information to know if those two triangles are congruent? I see a single, a double, triple, a single, a double, triple on both triangles. So I would say yes, because the three sides match up. So side, side, side. Take a minute and look at part F. On the first triangle, I have an angle, a side, and a side, which is the swear word. So that's probably not looking good. But on the other triangle, I have side, angle, side. So do you see how they're not, the first one is the swear word, and then the second one is side, angle, side. They're not in the correct order. They have to be in matching order. So this is not enough info. Please pause the video and try G and H. So this first example, they share this side in the middle. And so I have a single, a double, a triple, a single, a double, a triple. So this is yes by side, side, side. On first one over on part H, I have a side, an angle, a side. Then I have a side, an angle, a side. These match, side, angle, side, which is one of our choices. Part I, is there enough information here to tell if the two triangles are congruent? Well, I see I have two sides. I have a side and a side in the first triangle with a double and a triple mark. And then in the second triangle, I have a side with a double mark and a side with a triple mark. So I have two sides that match. I also have those extra arrows. You might notice these extra arrows here, which means that the top and the bottom are parallel. Well, remember, when you have parallel lines with a transversal cutting through, think about angle 1 and 2. You have alternate interior angles there. So I'm just going to make a note of that. Alternate interior angles. Angle 1 is congruent to angle 2 because the lines are parallel. So look what we have. We have a double mark on a side. We have an angle and we have a triple mark. Then we have a double, an angle, and a triple. So I think these are yes because we have a side, an angle, and a side. Similar on letter J. Again, this angle and this angle are the same because we have parallel lines cut by a transversal. They're alternate interiors and they will be congruent. Then we also have this side in the middle that they share. So if you look at the bottom triangle, we have angle, angle, side, and then we have angle, angle, side. So these are yes, angle, angle, side. Please pause the video and try to solve for x. All right, so you might have thought about this x over here, 2x plus 5. Well, they're on side xw. xw are the first and second letters. That would match up with bc, which is right here, which is 11. So some of you might have said 2x plus 5 equals 11 and solved it. And you get x equals 3. But others of you might have said, let's look at those angles. So for instance, this 77 is W. W is the first letter. It should match with B, which is this. So some of you might have said, oh, 24x plus 5 equals 77. Minus your 5. 24x equals 72. Divide, and you get x equals 3. So it didn't really matter which way you set this one up. Either way, x turns out to be 3, and you're fine. That's it for Unit 3, Section 4. So go ahead now and please try the practice. If you get stuck, let me know. Have a great day.